Well, thank you very much for inviting me. It's really an honor to talk about the EHDEN project, and it's also great to travel again and to be here in Paris. And I must say, I've been working with some of you that I see in the room in the last 2 years, and it's really great to be face to face and meet each other in that way. So looking forward to the break as well to talk to you. So I'm the coordinator of the EHDEN project, the European Health Data and Evidence Network project. And on the next slide, you'll see the, you can go one further. Yes, thank you. So the European Health Data and Evidence Network has a task to build a large network of databases standardized to a single common data model, the Omop common data model, and that's using a federated approach. So in our project, we do not share patient-level data. We keep the data local, and we bring the tools to the data, run it there, and share aggregated results back with a coordination center, for example. So privacy by design in that sense. Now, what's important to realize is that the EHDEN project is not only about standardizing data. So it's not merely a medical informatics problem of standardizing data at a large scale, but it's definitely also about evidence. So the second E in the acronym is extremely important for us. And we were quite happy with the name EHDEN because it sounds a bit like the paradise of data, but it's actually also very important that one of us thought of adding that second E, because it's really about generating evidence as well across Europe. So it's not enough if we map hundreds of databases. We definitely also have to run studies across those databases and generate reliable evidence for patient care. And I think we are doing that at the moment. So on the next slide, Erica, you actually see the full consortium of the EHDEN project. It's a large project. It's one of the larger IMI-funded projects with a budget of 29 million euro, with 23 different partners. And those partners are, as in all the IMI projects, it's a public-private partnership. So there's a lot of pharmaceutical companies involved, but also academia, with Erasmus being in the lead. And on the FPR side, it's actually Janssen who is leading that. It's a very interesting combination of people with a lot of experience that I think is really very useful at the moment in our project. And if you look at the budget of 29 million euro, you may say that's a lot of funding, and it actually is. But what's important to realize is that a big portion of that funding is used to standardize data across Europe. So it's a harmonization fund of 70 million euro that is blocked in the project for data sources to apply for funding to map their data to the Omop common data model. And next slide. So the image that you see here on this slide is really what I almost dream about. It's really about generating reliable evidence on source data, but at a large scale across many databases in Europe. And why is this image so important is all the individual steps from source data to reliable evidence. We need to be able to make them fully reproducible and transparent. And that is a very difficult task. Even if you would ask multiple people to implement a protocol, you will see different implementations of that same analytical pipeline. And we need to find solutions to avoid that. And we do that. And the next slide, Erica. Yeah, you can move all the animations, perfect. So one of the biggest challenges, of course, and we've talked about it, and I think the introduction from Emmanuel was already great, there needs to be improved interoperability of data. We all agree on that. It's structure, it's semantics, but we don't solve all interoperability issues by just standardizing structure and semantics. The other thing is we need to make sure that we define, for example, cohorts or finding diabetes patients in databases in a very transparent and reproducible way. You do not solve all interoperability by just standardizing structure and semantic. You also need to understand how people can be found in certain databases, and that's not always the same across databases. But you need to make sure that you cover that, you understand that, and you can reproduce and reuse that information that you generate in that way. So data interoperability is at the core of the EHDEN project, but it's also about standardizing analytics. Sometimes we forget that. We think by standardizing data, we've solved the problem. Actually, that's the start of another big problem or a challenge, I would say, is to agree with each other what we actually mean with certain analytics. So when we say we do a drug utilization study across Europe, what do we mean with that? What type of tables are we actually generating to answer that question? What we don't want is different interpretations of a study across the community, because then again, we have another problem. Then we're all going to build different tools to answer the same question. And this is something that EHDEN and the broader Odyssey community are working on as well, to build those standardized analytics to answer questions that matter to us. And sometimes we have to do concessions. We cannot make it too complex, but we have to really focus on the core elements that are important to answer our main questions. And I've been involved in many studies across European databases. And one of the biggest problems always has been that people want to add more and more sensitivity analysis, more and more small changes to the protocol. And therefore, we never end up with like a standard way of doing things. And that's something we really have to invest in as a whole community. It's our own responsibility to come to a conclusion and say, if we are looking at incidence rates or incidence of disease over time, this is what we mean, this is what we do, this is the code to do it, and let's share that. The third component in EHDEN is data network. So building a large network of databases standardized to a common model, a common data model, and finally also building a strong community. Do not forget that you need to build something that's sustainable over time. Sustainability is not created by a project. It's not about the 5 million euro for the upcoming project. It's not about this funding from EHDEN. You need to create uptake at a very large scale and get people very enthusiastic about it and move the whole world themselves. And I think we are trying to do that with EHDEN and with Odyssey in a very nice way. So the next slide. Yeah, you can move one forward as well. Thank you. So we are actually splitting up that whole journey into two different steps. One is the standardization to the common data model, and the second step is building the analytical pipelines, that M step. And that creates an opportunity for us to scale up in a much better way than was possible earlier. Next slide. Thank you. Yeah, you can move one further as well. Thank you. Yeah, so one of the important components in EHDEN is building the data network. And as I mentioned, there are open calls for data partners to sign up. They can get up to 100,000 euro support to map their data to the Omop common data model. And currently, EHDEN is working with 140 databases across 26 different countries. And I thought it would be useful just to show a screenshot of the EHDEN website where you can see all the data partners, to show which data partners in France are actually at the moment getting funding through the EHDEN project to map their data. And Health Data Hub is one of those. Could you move to the next one? Thank you. Also, besides data partners, we are training small to medium enterprises, so small companies in all the countries, to help with the mapping. Because it's a lot of work to do the mapping, and you need support from a broad community and creating business for those companies to map to Omop and also to support the maintenance of it, etc. And EHDEN is certifying SMEs across Europe. At the moment, there are 45 companies certified you can find on the website. And these companies can help organizations to map to the common data model. Next slide. Now, EHDEN is part of a bigger community called Odyssey, and we are building very strongly on what Odyssey has been creating, including the common data model. And I can highly invite you to have a look at the Odyssey community. It's very, very large, many different active organizations across the world, where we are, of course, in Europe, but also in the US and in Asia. There are many data partners that are mapping to Omop or have mapped to Omop, but also a lot of researchers and research groups that are maintaining or driving different work packages within the Odyssey community. Next slide. Also, a lot of European projects are now building on Omop. I think that's another important aspect of sustainability, that outside of the EHDEN project, there are other IMI projects, other European funded projects that are using Omop as their basis and then build their more project-focused addition on top of that. For example, focus on diabetes and working on building tools and getting databases mapped to Omop. So very, very important, I think, for sustainability. And next slide. Yeah. And also the use of the data to answer questions. I think that's one of the important things I mentioned in the beginning. We are already running studies across databases with Odyssey and with also the EHDEN databases to answer questions that really matter to patients and inform regulatory decision making and of course research in general. And I think that's a proof of the whole concept. And I would invite you to have a look at the website where there's links to many publications, very good journals, I'm happy to say, that impacts, I think, our clinical thinking. Next slide. And also, is the Darwin EU project, the project initiated to build and maintain a federated network to answer regulatory questions, is of course another example that shows that the Omop common data model that we've been pushing will now land in this space. And I'm very happy that from Erasmus Medical Center, we are setting up the coordination center for the Darwin EU initiative, a long-term initiative, definitely not a project. It's something that should continue for a very long time. And we are setting up and establishing that coordination center to make that happen together with some of the partners you see on the slide here. And I think I then move to you, Erica, if I'm correct. Is that, yes?
Yes, and can you hear me?
Yes.
Okay, you can
well, my name's Erica Voss. I am in New Jersey in the United States. Like we said earlier, I'm a director at Janssen Research and Development, but today I'm primarily Peter's student at Erasmus Medical Center. And I'm going to talk about standardizing data structures. So Peter's already showed you this slide, and really, as a whole, we want to be producing standardized, reliable evidence. But on the critical path to produce reliable evidence, we need to standardize our data. And when I think about data standardization, I think about two things. I think about standardizing the structure, and I think about standardizing the vocabulary. Now, I'm going to talk about standardizing the structure, and then I'm going to pass the ball to Michael, who's going to talk about standardizing the vocabulary. So this is the Omop Common Data Model, and we've heard that kind of thrown around a little bit today already. And I'm just going to very quickly orient you to this by focusing you on the blue section of this slide. And the Omop Common Data Model is what is the structure that we use to standardize to. And we call this a person-centric model in that we have a database table that stores information about an individual subject or patient. And then all additional information that's gathered about that person is stored in other tables that are domain focused. So things like diagnosis goes in condition occurrence, drugs go in drug exposure, procedures and procedure occurrence. So the whole idea is that we have this person-centric model that stores all the information that you might get from different data sources. Over the years, we have been able to put data like registry data, survey-based data, general practitioner, claims data, all has fits appropriately within the common data model. But like Peter said, we have a community of individuals, and every year we're learning more about different types of data. And so that the Omop Common Data Model over the years does grow and expand to accommodate different data sources based on what the community thinks it needs. Now, I want to make standardization of data a little bit more tangible, and so I'm going to provide an example. On the screen, I'm showing an example of 4 different databases and how they capture information about diagnosis. So I've got PharMetrics Plus, LRxDx, German DA, and ambulatory EMR. These are 4 different databases, and these are just examples of diagnosis data. So at the top here, I have 2 different claims databases. So the data itself is similar, but you can see looking at the slide that the way the data is being stored is slightly different. So in PharMetrics Plus, the diagnosis data is in a table called claims. And then in LRxDx, the diagnosis information is stored in medical claims. So the table names are slightly different. If I want to find person identifiers in the claims table, I'd need to go into PAT ID. But in the medical claims table, I'd need to go to IMS PAT numbers. So there's different columns that I need to use to identify people. I can even see simple things like the way that we store time is different across these data sets. So you can start to see the complexity across these data sets. And those are two data sets that are similar. German DA is more of a general practitioner database. And here, if I wanted to find diagnosis data, I have to get two tables involved. So there's complexity in the way that I'd even pull the data out. And then this last database, ambulatory EMR, is actually looks a little bit simpler. It's just got a patient ID, a date, and a diagnosis. So what I'm trying to illustrate here is that if I wanted to do a study across these four different databases, I'd have to write four different sets of code because the table names are different, the column names are different, the way we're storing the data in the databases is different. So it's a lot of complexity. And ultimately, what a common data model gives us is that standardized structure. So I can take all these different data sets and standardize them into a single form. So in this case, with diagnosis data in the Omop common data model, I'm going to store that information in the condition occurrence table. So I can bring consistency to the structure as well as preserve source information. Now, you might be thinking, okay, well, I have data and I want to get it to the common data model. That doesn't sound like an easy task, but we have a method to move through that, and we have tools to facilitate it. So when you have a source data and you want to move to a common structure, we first summarize your data set using a tool called White Rabbit that teaches us about what is in each table and in each column. We take that summarization and we put it in a tool called Rabbit and Hat, where we can design the ETL. So we literally can draw lines from the source data to the common data model and think about how we want to do this transformation. We have tools like Usagi that help support mapping of vocabularies. And again, Michael will talk about that in a few moments. Once we've done our design, every data partner has to figure out how they want to implement their ETL because every institution has different technologies that they adhere to. But once you have a CDM, we can summarize your data by looking in tools like Achilles and start to see do things look correct. And we even have data quality assessment tools like DQD, so we can understand, does the data look appropriate? So for example, are there people who are born after they die? Maybe that doesn't make sense, and we can look into it. Ultimately, that gets us to a common data model. So that's a little bit about standardizing structure, but the next important part is standardizing terminology. So now I'm going to pass the ball to Michael.
Thank you, Erica.
Thank you so much, Erica. Yeah, so I'm with Odysseus Data Services. I'm the director for the terminology services in Odysseus. Okay, next slide. So that slide you already know from Erica. And we're now going to the second part, the standardized vocabularies. Next slide. Next. So the key to success, the second key to success is actually standardized content so that you can get to a complete solution, not only the structure that is represented in the CDM. Next slide. We'll be talking a lot about concepts in the next couple of minutes. And concepts are, in our terms, are medical terms that you can find in source data. So we'll be looking at atrial fibrillation a bit more. Next slide. This is how we have a representation, or we can see a representation for atrial fibrillation in our vocabularies. We're now seeing a concept representation where we can see there is a concept ID. It's unique, which is very important because that uniqueness makes it possible to work on the same concept in every database that has the Omop CDM. And then we see the obvious stuff. We see a description. We have a domain that's assigned to it. That domain also kind of determines where that particular concept should go to. In that case, it should go to the condition tables, right? It's a condition, it should be there. This is how a person with a patient with atrial fibrillation in their source data would end up with a concept like this in your Omop CDM in the end. All right, next slide. We have three different kinds of concepts. I just talked about a standard concept before. The standard concept is a classic target for us. We will all want to converge our source data into one of these standard concepts. So wherever you have an atrial fibrillation, it should end up in that standard concept we've just been seeing before in every Omop CDM database. Then we have the non-standard concepts. The non-standard concepts are very often the source concepts. So this is how your coding system, your local regional coding system, has a code for atrial fibrillation. And there are so a lot more non-standard concepts than standard concepts. And this decision is being made. At some point in time, we decide this should be the standard that we all try to focus on, while the others stay non-standard concepts. We'll go to that a little bit more later on. And a third category are the classification concepts. Those are rather used on top of the existing concepts and more to perform hierarchical queries. So a classification can point at many standard concepts. If I have a rough classification and I'm more interested in getting as many standard concepts that I want to have in my research, in my analysis, then I can pick that and end up with the standard concepts that are assigned to them. Next slide. This is how the vocabulary is basically built. We have one table concept. If you remember the diagram that Erica showed you before, that's pretty much in the middle, the vocabulary section in, I think it was orange. We have all concepts end up in this table. Then we have the concept relationships. They represent all the relationships between concepts. Those can be mappings from non-standard to standard, allowing us to use that in ETL, but also other mappings, such as internal hierarchies. A third table is what we call the concept ancestor table. It's being generated out of existing concept relationship entries, but only between standard concepts to represent a hierarchy in these standard concepts from, for example, less detail to more detail. Next slide. Here's a network graph that shows us lots of vocabularies. All of these vocabularies have been consumed by the Odyssey community into the entirety of the standardized vocabularies. And we see the ones with a green circle as an indication of having many, many standard concepts or more standard concepts and non-standard concepts. That also shows the backbone of the standardized vocabularies, which is SNOMED, RxNorm, LOINC. So many of the other vocabularies that we have, they point to those standard concepts in these vocabularies. I'm not saying that RxNorm is a standard vocabulary, but I'm saying it has a whole lot of standard concepts in it. Other vocabularies can also contain standard concepts, but normally to a much lesser degree. And that's always the case if we cannot find a good target match in one of the existing vocabularies.
I'm sorry to interrupt you, Michael. I think we'll have to speed up a little bit because I think Peter will need to conclude if we want to keep a few minutes for questions.
Yes. Next slide, please. So next, because there's an animation. Okay. So we'll be focusing on the standard concepts and the source concept. Next. The source concepts is what you know from your medical data. And the standard concepts is what we will end up after the ETL in your Omop CDM database. Next. You are already familiar with this slide. So next. This means, again, I just adjusted it for atrial fibrillation. This means, again, we have 4 sources, different coding systems, but we want to end up at the same place. Next. So this is how it's represented in Athena. Athena is the place to host all the vocabularies. We can see there's an ICD-9 code for atrial fibrillation and flutter, and it goes to the SNOMED code for atrial fibrillation and Flutter with an internal concept ID. Next. The same can be found for ICD-10-CM. So we have that, and it goes to the same code in the concept. Carry on. Next. So what does it mean here? All of these end up in the same, but on top of that, also, we have created concept IDs for the source vocabularies, right? So in your Omop CDM, you keep the information. Where did it come from, but also in a structured way. So all of this relates back to the vocabularies. Okay, next. And that is, sometimes you have to do this, and that is what Erica pointed out as use of Usagi. Sometimes your source data is simply not coded in a vocabulary that we already have in Odyssey. And then you have to do this yourself. You have to look at the sources, find out the codes, and then map them yourself to the proper target. Next. What did we do and what is required for HDH data? So we have SIM10, the ICD-10 equivalent, that's already in the Odyssey standardized vocabularies. We have CCAM, procedure codes. We only have source concepts in Odyssey at this point, need a community effort by the French community to provide the mapping, which will probably happen. And then we have some targets for drug concepts from UCD and CIP, not so many for the NABM measurement or service coding. Next, please. So last slide from my side. I invite you to visit Athena Odyssey.org and explore the vocabularies. They are, except for a couple of licensed commercial ones, they are free to use. Get a user, look at them, download if you want. Thank you.
Thank you, Michael, and thank you so much for speaking up. I'm sorry. I think Peter will wrap up right now, and then we'll be able to take maybe one questions.
Sure, I'll do that. It's only one slide. I just want to mention that there will be a symposium in Rotterdam in June. A lot of people will join there that map to Omop, that are building analytical pipelines. So you're all invited to join there. It's at a cruise ship. The cruise ship is not moving, so you're not going anywhere. But it's nice to be there together and all have a lot of discussions about that. And then the last slide is actually some links to the book of Odyssey. There's a book written describing all the things that we have been discussing, which is way too much information. Anyway, but you can find it in the book, I think, quite nicely as well. So thank you very much for your attention.
Thank you very much. So thank you very much, Peter, Erica, and Michael, for this very clear and informative session. I think we don't have so much time, but we can still take a question from the audience if you have any. Yes, right here.
Hello.
Yes.
Thank you for this presentation. How do you intend to validate the implementation of the Omop?
Yeah, so there are different methods to do that. Of course, you could run something on the source data and on the CDM and see if you get the same answers. That's something that people are doing. But also the ETL and the whole process, making that completely transparent and reviewed that by multiple people is something that also is happening in the community. And there are other tools like Erica has been talking about, like the data quality dashboard, which gives you a lot of insights in the quality and whether you are actually whether you have actually mapped to the right table, and there are a lot of checks in that dashboard, which is quite useful, I would say. It also shows a lot of things on your source data, which would be interesting to fix even outside of the CDM. Yeah.
Thank you. We also have one question from the chat. How long does it take to convert a data set to Omop per patient, for example?
Yeah, very good question. Not so much per patient, it's more about the complexity of the data. So we have seen a wide spectrum of that. The main limitation is actually the readiness of the source data. So how ready is your own data? Have you actually collected all the data into one spot? Is it research ready? Once that's the case and you have a not huge amount of tables, it can be done in a couple of months. But I've seen also situations where there are hundreds of tables in the source data with a lot of redundant information that actually shows why it is so important to move to CDM, but it also creates a burden. It's a limitation, and it will take more time to get there. What we do see is that it's useful to do a kind of incremental approach where you start with the tables that are important for your use cases and then expand on that later. But it could be a big effort, but it's worth the effort, I can tell you, to then be able to participate in international collaborations.